Now it's your turn to try to answer the following question on your own first. An 8-ounce serving of Pepsi contains 25 milligrams of caffeine and 27 grams of carbohydrates. How much caffeine and how many carbohydrates are in a 20-ounce bottle of Pepsi? If you have not already attempted this problem on your own first, please stop the video, return to your lecture note packet, attempt the problem on your own, and then return to the video to check your work. Reading the problem the first time, I recognize we're dealing with Pepsi and how much caffeine and how many carbohydrates are in a certain size bottle. I also recognize that the amount of caffeine in a bottle and, separately, the amount of carbohydrates in a bottle are completely unrelated. In being asked how much caffeine and how many carbohydrates are in the 20-ounce bottle, we are essentially being asked two separate questions. This is really two questions in one, and I will need to approach each question separately. So as a starting point, we'll begin with the amount of caffeine. We know from the information given in the first sentence that an 8-ounce bottle contains 25 milligrams of caffeine. That ratio will become a basis for answering the rest of the question. I know whether we're dealing with an 8-ounce bottle or a 20-ounce bottle, the ratio of Pepsi to caffeine is not going to change. Therefore, I can set this ratio that we know equal to another ratio that's missing a piece of information. I know in the other bottle we're going to have 20 ounces. What I don't know is how much caffeine. I'm going to choose to use the letter F to represent the amount of caffeine, and I'll now go back and formally define what F is representing. Let F represent the amount of caffeine in milligrams in a 20-ounce bottle. Again, because caffeine could be measured in different units, we want to specify specifically in this particular problem, we are dealing with milligrams. Taking the equation that we've set up and removing the units, I'm essentially trying to solve the equation. 8 over 25 equals 20 over F. To solve that equation, we'll follow our standard process for solving proportions. We'll multiply both sides of the equation by both denominators. I'll multiply by 25 and by F on both sides of the equation. On the left side of the equation, the 25 in the numerator and the 25 in the denominator cancel. On the right side of the equation, the two F's, one in a numerator, one in a denominator, also cancel. So this leaves us with the equation 8F equals 20 times 25. Personally, not being inclined to do intermediate calculations, I'll leave the equation as 8F equals 20 times 25 and ask myself, what do I need to do to solve that equation? Since I'm trying to isolate the F, I need to eliminate its coefficient. Since we're multiplying by 8, I will divide both sides of the equation by 8. And in reducing that equation, we end up with F equals 20 times 25 over 8. I will bring up my calculator to do that calculation. Now with the calculator open, 20 times 25 divided by 8 is 62.5. Therefore we know F equals 62.5. As always, I'm going to check this. So I'm going to make sure 8 ounces being compared to 25 milligrams is actually proportional to 20 ounces being compared to 62.5 milligrams. We'll again use our calculator and check that these two fractions have the same value. So now checking, 8 divided by 25 is 0.32, and separately, 20 divided by 62.5 also gives us 0.32. Since we do obtain the same value on both sides of the equation, our 62.5 solution does check in the equation, it does check back in the original problem, and all we need to do at this point is answer the question. How much caffeine is in a 20-ounce bottle of Pepsi? There are 62.5 milligrams of caffeine in a 20-ounce bottle of Pepsi. We've now answered the first part of the question, how much caffeine is there in the 20-ounce bottle of Pepsi? We now need to answer the part about carbohydrates. Since the work is unrelated, I'll need more space to answer that part of the question. As we start the second part of the question, it will be very similar to what we did for the first part. The only difference is we're dealing with a different substance and a different quantity. But we still know from the first sentence that there are 27 grams of carbohydrates in an 8-ounce serving. That's the ratio that we know. The ratio that's incomplete, that's missing a piece of information, is the second part. In the second bottle, we know that there are 20 ounces, but we do not know how many carbohydrates. I'm going to use H to represent the amount of carbohydrates in the 20-ounce bottle, and I will formally define that now. Let H represent how many carbohydrates in grams are in a 20-ounce bottle. In solving this equation, first I will drop the units and rewrite it as 27 over 8 equals h over 20. In this situation, I could approach this as a standard proportion and multiply both sides by both denominators. But I could also look at this as we're simply trying to solve for h, and currently h is being divided by 20. So all I need to do to solve this equation is just multiply both sides of the equation by 20. At this point, I'll pull up my calculator. The calculation we need to do, 20 times 27 over 8. We see the calculator returns 67.5. Therefore, I know 67.5 is equal to h. As always, I do want to check my answer. So the question is 27 grams in an 8-ounce serving proportional to 67.5 grams in a 20-ounce bottle? Again, we'll need to use the calculator to do these two calculations. On the left side of the equation, 27 over 8 is 3.375. On the right side of the equation, 67.5 divided by 20 is also 3.375. Since these two values are equal, it does check that we have the solution for our equation, and in turn we do have the answer for the question. The final thing to do on paper is to actually answer the question. How many carbohydrates are in a 20-ounce bottle of Pepsi? There are 67.5 grams of carbohydrates in a 20-ounce bottle of Pepsi. One thing I would like to point out for this particular example is that in the first half, when we were figuring out how much caffeine there was, you'll notice we set up the ratio as volume to milligrams, so volume to caffeine. In the second one, we set it up exactly the opposite, the substance of carbohydrates compared to the volume. One nice thing about every ratio proportion that you set up is there are multiple ways to set it up correctly. The key is that the ratio you set up on the left side of the equation has to be using the same structure as the one you use on the right side. As long as you're consistent in how you set these ratios up, there is no single correct equation to set up to answer the question.